Hello and welcome back. My name is Corey and you're my rubber ducks for the evening. And this is the series of episodes where we are building Tang, right there, a template language, a custom programming language built from scratch using our bare hands and, well, C++, a terminal window, Vim is our text editor, Flex, Bison, ICU, Google Test, and hopefully experience and stuff like that. I don't know. All of this is 100% live coding. That means you see my errors, you see my syntax problems, you see me figuring out how to solve problems, you see me making mistakes that I might not catch right away. But hopefully by the end of each episode, we do have a compilable result. And so let's do this. Let's switch to the code base, and on the right hand side I will do my customary make clean and just get our compile started. And what are we trying to do today? We are wanting to continue on our bytecode analysis, finding things that we can fix. And today's going to be harder because we've got to do some stuff with removing bytecode, right? So we generate bytecode and now we're going to analyze it and figure out stuff that we can remove from the bytecode. So yeah, let's continue, shall we? We're going to, on the left hand side, why is this not showing up? There we go, get log. The last commit that we did was episode 83. That was the previous episode, and it was the last commit there. And if we say get status, there's no changes. And so we're just going to jump in, and I'm going to open up our test file because we can use that. And we have our where is this? Well, we're going to edit the include for program and the do I want to do that? Yeah, that's fine. I'll do it. No, you're saying what? Do what? I'm thinking out loud. And then our source for program, I think, is it dash analyze? Yes. All right. Now we need a what's the first thing that we're wanting to do? Probably something with an, where is an if statement? If else. And what would this show if I do cout p1 dot dump bytecode? What would this show us? In other words, I'm looking for a specific pattern, and so I'm thinking this null value followed by a pop. Null val followed by a pop. Yeah, that's what we're going to look for, that type of a pattern. And the goal is that when we dump the bytecode, before and after, that this kind of number 16 should, peak 0 should move up. I really kind of wish that I had something maybe a bit more sizable. So this has an if true, a is equal to 2, and then a. Maybe this if else. Let's do replace that with 6, and does it have a bit substantial bytecode? This one has, there's the pop, there's a pop. This doesn't have that pattern. What about 8? Basically, I'm looking for the pops, which will help us with how our code is going to work. We're going to look for a pop. Nope. So, but it does happen here. Oh, I see why it would do it. Well, there's two reasons why. In this case, it's assigning a value to A. Yeah, it's assigning a value to A, and then it's immediately accessing the value of A. That's why. Okay. But that should... But that's not what I'm looking for. I'm looking for where it's putting a value on and then immediately popping it. You know what? I know how I can do this, how I can force it. And we're just going to say test optimization. No. Nope, that's not the one I want to test. I know how to write a test for one in particular. You know what? We're just going to stop here. Say, Corey, what are we going to stop and do? I'm going to be able to find one, but I will write the code to do it. So let's continue then. So we've got our analyze here, and I don't like how we've got these two types, the pair map, and have to have them in two different places. So what we're going to do is just going to have a using clause there. And this first one, let's... I'm wrong. This one here. That. All right. And what is this? So that's an opcode of vector size. So what did we call this? Opcode offsets? Let's use that. This is going to be a to a pair of offsets. And first in the there. With the first position being the bytecode offset and the second being the ops offset. Being the, let's have a better wording for this. Second position being the I mean, it is an ordinal. It's not really a position. The nth opcode. Yeah, array. That's fine. All right, so that is going to be now be called opcode offsets. I like that wording better. The position of the opcode relative to other opcodes. And this, you know, there, the position of the opcode relative to the other opcodes, e.g. the nth position. There. That should be fine. And now Let's grab the other one. What is this going to be? This is going to be... Need more room. That's what it is. There we go. List of opcodes. In positional order. Each entry is a pair specifying the opcode and the bytecode offset. Yeah, bytecode offset. That's fine. And what should this be called? Using opcode positions. Sure. Opcode positions. And now that's what we'll call this. Opcode positions. And what does it not like about this? So it's in the namespace Tang. Opcode offsets, opcode positions. Oh. Needed a semicolon. That's what the problem was. All right, so this is a little better. There we go. And this should be all right. And so this is analyze, and the purpose of analyze is to return it's just to return these two data structures. So then program, analyze, dump, execute. How about just program itself? We call compile. What does compile do? Prepare, reserve spaces on the stack, compile the program, and then the last thing is release the environment. That should be fine. And then the very last thing would be optimize the bytecode. And we're going to do that as optimize. This arrow optimize. Doesn't exist yet. We're about to write it. It's going to be a hidden, I think. Oops. Analyze. It's going to be a void, optimize, and it's definitely not a const. And now we need to create this. Oh. Yeah, we don't have that optimization test. Okay. We need to... Do we need to copy? Do we need to touch? You know, let's just do it. Let's copy source program analyze, and we will call that source program optimize. Is that what I just wrote? Yeah, optimize. That's fine. And our make file dump execute there. And except for, instead of analyze, it will be optimize, and we will need the program and the opcode. Okay. That is not right. There. Those should not have had slashes at the end. I'm guessing it's working because I had an empty line, but still. All right, multiple definitions. That's because we need to fix this. So edit our source program optimize. There we go. And this is now going to be there. Void program, not a capital, optimize. And it's going to do something. What yet? We don't know. What do we need? Do I need string streams? No. IO manip? Well, I might, but for right now, probably don't need bit or CMath. I think I only need program and opcode. And if we do this, now everything should compile. Everything is compiling. That's always a good thing. And if I edit source program, was it dump bytecode where I put that code at the end? Yeah. There we go. Now, what do we do? Well, if I just do this. What's it going to do? Oh, out is not declared. That's okay. I can do cout for right now. Cout, cout. And it's going to output a lot of stuff. Yeah, that's a lot. For right now, though, just so I can see what I'm doing, I'll do that. And I'm going to say for size ti is 0. Sure, I'll do it like that. No. I'm going to do 1. Why? Because I'm looking for an op pop. Yes. For size t, it says I is less than, and it's going to be ops.size plus I. All right, so this will go through, and now we're going to say if, oh, because the make file is open. Okay. All right. So I'm going to go through and I'm going to say if ops sub I, now that is going to be an opcode. So if first is equal to opcode pop. Now, what all would the previous thing need to be? We need to see edit. No. Let's WSL view docs HTML index. There we go. Bring up our documentation. And I think it's easier to have a set here. So a set, okay. Oh, and I need strings. Nope. A set of opcodes, and we will call this no. And let's get our list of them. It's probably going to be under here. Oh, I should just be able to search for opcode. Yeah, Yeah, so we've got null val, and we'll start there. Integer, float, boolean, string. Now, I don't think I should check for array or map. What about library? I would have to pop. No, it has a. So basically, I'm trying to anything that pushes something onto the stack. But if it pops something, the stack needs to be taken care of. So this pops, this pops, this pops something. Get an index and save the top of the stack to to a library, but that won't pop. That doesn't push anything. Okay, that doesn't push. Get argc. Push the function. It pushes it, but it doesn't pop anything. Yeah, so a function can be there. Any others? Okay, so these. Well, let me do that. Sorry, just trying to move this out of the way in case I need it in the future. And what I want to do is say if that and something else. Now, I don't have to include the parentheses here, but C++ set. I think it's just count to find out if something is in a set. Count. Yeah, count. All right. And count, and what are we looking for? We are looking for op sub I minus 1 if the preceding one dot first. Okay. Then we have found a set of opcodes that can be removed. Now, how do we remove them? Probably should just comment it all out. I was afraid though. Yeah, it's going to say unused. For right now, we'll see if this will work. Yeah, it'll compile without me doing that. See out here. We're not doing anything. It's just we're identifying that we found one. Okay, so there's several places where this is true. What we need now is we need to have a remove opcodes. And what do we need to give it? We need to give it the bytecode. We need to give it I-1, remove 2, and then it will need to fix op, offsets, and ops. Yeah. So let's write this function, shall we? It's a static void remove opcodes, and what is bytecode? Code ampersand bytecode. Okay. A size t position, a size t count, up offsets. What is that? What type is that? I don't remember what types I created. So, edit, include program, are using opcode offsets and opcode positions. Yeah. Opcode offsets, and we'll just say op offsets. And opcode positions, ops. And see if that compiles. Oh, just a bunch of unused stuff. All right, so I need to, just to get this to compile, because something tells me we're gonna again, just hoping it compiles. Yes. All right. Now, where we are right now is the reason for this video. You say it took us 30 minutes to get here? Yep, it did. The real meat of this is how do we remove these opcodes? Now, in fact, I'm going to, let me go ahead and write the help text, so to speak, for this. So this will be remove opcodes and their associated data from the bytecode array and the accompanying metadata arrays. Okay, so param. The first one is bytecode to be altered. The bytecode to be altered. Okay. Param position. The position of the first bytecode to be altered. To be removed. Count the total number of bytecode to, not bytecodes, of opcodes to be removed. The bytecode to be altered. Count. Okay. After count, we've got offsets, metadata, offsets, metadata. Ops is going to be and it doesn't have a return. All right, so what do we need to do? Well, what we need to do is a couple things. We've got to delete the opcodes from the bytecode array. Now we've been given a position of the bytecodes, but that is not the, the position of the opcode position of the first opcode to be removed. This is not the bytecode offset. Okay, yeah. So when we delete it, we can do something like bytecode dot, I forgot, is it erase? It's been a while. C++ vector, I think it's erase. Yeah, vector erase, and we can take an iterator first and last. So we can say erase and bytecode the problem is begin plus something. That's, and then bytecode dot begin plus something else, and we don't know what those are. Okay, so we're going to have to come up with that. Next, after we've deleted the bytecodes, we need to correct opcodes from opcode positions. Okay. Then we need to update opcodes in opcode positions after the deleted section. Okay. Then we need to remove deleted opcode entries from opcode offsets. Then we need to update opcode entries with new bytecode offsets. Is that right? Yeah. Opcodes after the deleted section in opcode offsets. Okay, so the whole point is we're trying to figure out, where are all of these, right? And then last but not least, update any jump targets that may have been affected. Okay, that's what all has to happen. Oh boy, that's a lot. So, where do we start? Well, it would be handy to know which one we're doing. So, here's what we're going to do. Instead of this cout here, we're going to break it. And how are we going to break it? By setting this bytecode sub 0 is equal to opcode jump, an unconditional jump, and where this bytecode sub 1 is equal to this bytecode size. And just exit. So that should break. Have to cast it. I should know this by now. All right. We have successfully broken things. So now, we broke 2 in the ranged for only 1 in the control flow. Yeah. I like having just 1. So it's 1346 in test. $13.46. And this makes sense because we've got a for loop that because we're checking the result. Why are these? Well, stack is empty, blah, blah, blah. That's fine. Well, I'll work with this. Just well, sorry. Okay. I keep arguing with myself, and all that what I need to do is, where was that one that only had 1 in it? 1346. Okay. 1346 is this one, which means it is this one, which means everything outside of this we're going to comment out. Evidently, I don't know how comments work. All right, so you should still have that error, and then I want to change my make file so that I'm only checking control flow 4. And filter is equal to control flow dot 4. There. It's only doing that one. Now we've got the here, and what I want to do is I want to say cout dump bytecode. So we should print it out twice. Oh, because I'm returning. Well, duh. So now it should print it out twice. You know what? I think this is even easier to do it like this. If I say auto before is equal to that, auto after is equal to that, if before does not equal after, see out the before, followed by that, followed by after. There. That should still work. Now it won't print out anything because we're only doing one. We should probably just see out before. And then there we go. So that's the before. And what we should be seeing somewhere is like this null val followed by a pop. And how do we know that? Because up here we should be able to say cout position count. How many times? Tend to? Oh, there's two of them here. Oh, okay. Well, wait. So already we're not getting the right stuff. Position followed by count. The count will be 2, but if the first is pop and the one before it is one of these producing ones. Oh, 10 would be 1, 2, 3, or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the null value. The 10th one. 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20, 21, 22, 23, 24, 25, 26, null value followed by a pop. So yeah, those are right. Okay, so those are not the bytecode, which is what I need. So how do we get this? So auto, yeah, bytecode to remove start is equal to ops sub position, and that is that going to be second, I think. On the right-hand side, no, I'll just leave that what it was doing. Sorry. I'm going to edit. Oh no, include. I've already got it. Yeah, this will, at the position is going to be an opcode and then its size. Okay. And what I need to know is, or its location. I just exited. I didn't mean to do that. That's okay. There, all the files are back. End is equal to ops dot size is less than I plus, is that right? Position plus count. Because if I'm at a certain position, in fact, if ops dot size is greater than or equal to, no, less than. Position, then return. Yeah. This is just a sanity check to make sure that do I need to do that? Scope. Okay. Available opcode positions. Okay. So what we're going to do is we're going to say the position plus the count. If the size is less than or equal to, would that be right? So if the size is 3 and I want to remove all 3, it would be 0 plus 3. At that point, I need to know the ending one. Well, actually, so the ending is 1 past, so it would need to be a 0, 1, 2. It would need to be 3, yeah. So the opposite size, position plus count, 0, 3 would be equal to the size. Two. Yeah, so what I'm trying to do is I'm just trying to make sure I don't have a stupid off by 1 error. Here's what I'm thinking is if I have, a 0, 1, and 2. These are positions, 0, 1, and 2. And I say I want to delete from position 0 to position, and I want to delete 3 things. And that means I would start at 0 and end at wherever the third thing is. Because that would give me deleting 0, 1, and 2 and not including 3. Okay? But if I've only got 0, 1, and 2, I can't ask where the position 3 is because I need to know how many bytes. Because this doesn't know what kind of opcodes they are. So if its size is 3 And what I'm asking for, position 0 plus 3, that's the position I need. If that is greater than or equal to, in fact, it might be easier to do that. If position plus count is greater than or equal to ops.size, then just do ops.size. Else, and there. Else, do ops position plus count. Yeah, this makes sense now. Dot second. Is that right? Bytecode to remove, and I'm saying end. Is it really the end? How about exclusive end? Because that means up to but not including. Okay, so now oh, and it doesn't like that, but that's all right. We'll get that. So auto bytecode to remove count is bytecode to remove exclusive end minus bytecode to remove start. You know, we could just call it bytecode start. All right, and is this correct? So if, let's just pretend that these are actual. So let's say there's a 3 there. If it starts at 0, 1, 2, 3, 3 minus 0 would be 3. Yeah. What if it's only 1? Whoops. What if it's only 1? Well, then this would be a 1. And I would say whatever bytecode that is minus the exclusive end. Or, sorry, exclusive end, which is 1, minus the start, which is 0, be, say, remove 1. Okay. All of that looks correct. Now we get to have fun. Bytecode.erase. Begin plus bytecode start Do I not need the count? Well, I think it's going to be bytecode deleted. How many did I delete? Or count is less than 1. So there's got to be something. The question is, oh. So when I'm going through, I need to back up because it could be that there's more than one. So I is equal to, how about I minus equals 2? Is that right? Backing up 2 because I just removed 2. Think of it this way. If I've got this pop null, if I'm pointing at this one and now I delete 2, jump is going to be here, and it could have been a pop to go with that. So yeah, I need to back up 2. All right. So in theory, now, as of this moment, I could run it, and I think we'll see that it does the bytecode. I just want to do one of them, and I'm going to say I is equal to ops.size. How about that? Unused, I know. We will be using it later. All right, so I know it's failing, but the point is what we should be looking at is, before we had a null val and pop 1920, and the question is now null val pop followed by a peak and then integer, and now it's null val poke pop peak integer. That's what it should be. Poke pop peak and integer. Now you notice our annotations are now wrong. Add that to our list of things to fix. Bytecode. Offsets. Okay, that's in our to-do list. All right. In fact, let's do that first. How do we do this? set annotation. It's called annotations, and it is a map. Remove any annotations that are associated with the remove bytecodes. How do we do this? Well, let's see, for size t I sub bytecode start, I is less than bytecode exclusive end. I plus plus I. If this is it annotations? Annotations dot count I is, yep, it's a size t. Okay. If it's there, then this annotations, and that's a vector. Erase requires an iterator. Is there pop back insert? Oh, no, wait, sorry. I'm looking at a vector. I need map. Map. Just map. Clear is all, and we don't want that. Is it just erase? Turns the number of elements. Can I just do it that way? Can I just call erase specifically without checking to see if it exists? About to find out. It is erase, isn't it? Erase key type. Oh, I don't have access. We should probably get the annotation, shouldn't we? And I think we're going to delete that there and just give it another using type. Offsets to a string identifier. Annotations. How about we call this opcode annotations? Sure. There we go. So now we've got this opcode annotation. It's going to have to rebuild everything. But in the meantime, we can go to our to and pass in annotations because we have to fix those. And so instead of this, it's just going to be annotations dot erase, and then we need to pass in annotations. And of course I didn't add it to the So, all right, so what are we checking? It's not giving me any errors on the deleting them. Now we need to go through and for any annotation that is after this. So, move any annotations that are with bytecode positions after the deleted section. All right, so what do we need? We need to have known how many opcodes there were at the beginning. So we're going to say auto original bytecode size count. Well, it is a size. Okay, size is equal to ops.size. And now for size t, I is bytecode exclusive end I is less than original bytecode size plus I. And what are we going to do? We're going to say if there's something there. So if annotations.count I, then we need to annotations sub can I move? Is there a fast way? There's a swap, but that's not. In place isn't the right option. Here's what I think I'm going to do. I think I'm going to say swap annotations sub I and annotations sub I plus bytecode deleted count. Swap those two, and then annotate. Nope. I'm wrong. That should be a minus. Annotations dot erase I. Okay, so go through this again. So I is the old, so it's whatever we were ending with before up through the original size. If there is anything in the annotations with that number, then swap it with a lower number, which won't exist, but since we're using this add, it should do a default constructor and then just erase that, which will be a default constructed one. So annotations, can't spell. All right, so what I want to see is, first of all, after 18, do we get something before peak? After 18, we do identifier I loaded from stack, and that's what was originally at 21. Now it's with that one. Okay, and how about this one? It was originally, now it's with 36, excuse me, integer 1. But did I miss something? Let's do that again. So null val pop, and then what was with 21 should now go with 19, right? Yes. And what was with 28 is now going with 26. What was 36, is that now pointing at, no, it's still pointing at 36. It did not get moved. Why didn't it get moved? That is a very good question. So this one did get moved. Peek, peek. After that, pop. We could just say moving, well, let's say I to I minus count. (21 to 19, 28 to 26). Move 28 to 26. Why didn't it go all the way up there? Is it because original bytecode size? Oh, it's not going far enough. It shouldn't be ops, it should be this bytecode. Not this bytecode, just bytecode. So it's working. And now it moved 36 down to 34, 49 to 47. Okay. That's nice. I think I still like the swap. It's cleaner to me. You know what? Now I'm wondering, can I do this? Can I do is equal to move? I don't think it'll do it. Yeah, it still thinks that there's something there. You know what, though? I think I like that better. Annotations dot erase I. Okay, and what was 21 is now at 19, and all the way down to what was at 49 is now at 47. So they're all associated at the right place. Okay, a lot of work, but we're there. Okay, so that's our annotations updated. And we're only removing one thing, so let's just keep going. Delete the opcodes. All right, so we deleted the opcodes and we moved the annotations. Now we need to fix the bytecode and opcode metadata. First, remove the opcodes from open positions. Opcode positions. What is opcode positions? That's our ops. Oh, yeah. So that should be size ti is equal to position I is less than ops.size plus I. And I'm going to do this first. So position is where we're going to start removing stuff. And let's do position plus count. And all that we need to do is then say ops sub I, and this is going to be dot second minus equals bytes bytecode deleted count. That should be correct. And then ops dot erase ops dot begin plus position ops dot begin plus position plus count. And that should delete. Okay. And what I'm going to do is at the end, really quickly, just to check, for auto I in ops, it's the bytecode and the position in ops. See out the bytecode followed by the position followed by an inline, and this is just for me to double check really fast that it's working. Now what I would expect to see is that we've got peak should be 47. And it is. What got deleted? No val pop. So there should be a pop at 18 and then a peak at 19. Pop at 18, peak at 19. So that did it. Okay. That was a lot simpler than I expected. So 1, 2, remove opcodes from opcode there. Okay. What about, yeah, opcode offsets? So opcode offsets is an interesting one. We've got 2 entries to update. I was going to say it'd almost be easier to just rebuild it, but that's not quite. No, it would be, because we still have to go through the vector and find the pairs. No, we'll still do it this way. Sorry, B2. So is there actually no? So we can do this. What I'm wondering is there a fast way in a vector? Vector, vector, vector. There is the erase, but is there a delete? I don't think so. Erase elements, and this is with a at a specific iterator position. That's fine. So for auto IT, and this is going to be, so the opcode offsets, what is that? Op offsets. Nope, 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 nope. So offsets in op offsets. What I'm thinking of is I should actually probably do this as, because it is a map of an opcode and the offsets, which is a vector. And now, what do we need to do? For auto IT is equal to offsets dot reverse begin. I want to start at the end, and offsets IT does not equal to offsets.rend, and I rarely deal with iterators, and especially reverse iterators, so I hope I'm doing this right. Plus plus IT. What is my goal? Well, what I want to do is I want to say if, because what is iterator? Auto ampersand it has two offsets in it. So the bytecode versus the opcode offset. Bytecode, opcode. So the bytecode offset and the offset, offset, offset. There. Equals star IT. If, now what could happen? The bytecode offset if it is greater than or equal to bytecode exclusive end. If that is the case, then we need to adjust it. Offset minus equal bytecode deleted count. And offset minus equals count, because that's how many were deleted. I think that should work. Else, if bytecode start. That's what I was looking for. If B offset is less than bytecode start, then IT is equal to offsets Can I just break? I don't think I can break from here. I don't think that's right. Dot rend -1, so that it'll do the ++, and it should at that point be at rend. Else offsets.erase IT. Yeah, that is not good. So what I'm wondering is, it's a reverse iterator, but yeah, that's what it is. something like that. It's never safe to try to modify a vector when you're iterating through it. So what I need to do is I need to have a vector of, what is this? It's that. Reverse iterator. But it is a vector of, no, wait, I'm wrong. No, I was right. So it's a vector of that type, reverse iterators. So this, just so you can see, that's the type. It's a reverse iterator through that. And we're going to say to delete. And there we go. Now it should be and now this is in the wrong place. It needs to go inside. There we go. Okay, so we flag it for deletion, and then after we've gone through. So the way that this was created was that they're in order, right? And so we do a reverse, so we start at the end, and we know that, so if this is the case, then it is, there. We update the opcodes after the deleted section. Okay. Else, sections, so do nothing. All right. And is it because it doesn't like the fact? Well, let's just see if we can read this a little better. remove opcodes, blah, blah, blah. No matching function for call to. So a vector of pair of long, blah, 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 erase, given a reverse iterator of a pair long unsigned int, long unsigned int. Oh, from a reverse iterator to a const iterator. Okay, that's a good question. Let's see if there is a way. Random access iterator. Input, output. Convert reverse iterator to normal. Forward. That is interesting. Okay, so if I take the iterator plus 1 and get the base. Let's see if that works. Well, I got through the compile. That's good. We don't have any errors now. I mean, problems. So let's do this. Let's go through okay, we're going to cout op and line. And now for auto ampersand is of offsets be nice if I, had good syntax. And this is just to check the end result. Well, that's not good. It may be so we're only doing this one, and yet LT is really, really big. Oh my. Oh no, wait. What I did would work. Okay. So yeah, I'm getting a lot of gibberish, which means I probably let's just say, let's do this differently. Let's say auto next is equal to it plus 1. Offsets dot erase it. It is equal to next minus 1. And forget the whole deleted thing. Oh yeah. It doesn't know how to do the erase. And what did we have to do? We had to say IT plus 1 which is next.base. All right. So after the delete, let's see, we should have a peak at 47. So if we scroll up, we've got a peak at 47. And it says 28. It's the 28th thing. Is that right? Are there 28? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. I started counting at 1. Okay, yeah. Should have been the 0th, 1th, 2th, 3th. Okay, so peak, and so there should be a pop at 20 for the 27th. At the 27th, at byte offset 46. Yes, but there should not, well, there should be one at 18. One at 18. And one at 13. And 13 should not be changed, right? Because 13 is there. And 13 was here. But before, it was 18. Oh, 18 was a pop there as well. Still, all of these look correct. Yeah, they all look correct. And what did we lose? We lost the null val at 19. So is there a null val? Nope. 0, 1, and 42. All right, so these all look correct. Update any jump targets that may have been affected. And we've got the annotation. So the jump targets is the last one. And I think we will do that. Sorry, I'm looking for something in my code. That's what I was looking for. Jump opcodes. Which ones are they? That's a good question. Let's figure it out, shall we? JMP, JMPF, JMPT, JMPF pop. Oh, somehow I got these out of order there. JMPT pop. Is that all? 1, 2, 3, 4, 5. Just 5 of them? There. Nah. There. .count op. There we go. So yes, I'm iterating through them a second time for auto, and in this case, okay, so I'm going to go through, and all that I need to do is the bytecode offsets. So if the bytecode offset, so why didn't I do it earlier, by the way? Well, let me just put that here. We did not do this earlier because the first check loop short-circuited or exited early. Yeah, we'll say that. It exited early. To save processing time. Nah, just say processing time. Okay, so if the bytecode, nope, we got to check each one, and that is not what we're checking. So if bytecode offset +1, that is the target. So in fact, we'll just say auto target is equal to bytecode offset plus 1. If target is greater than bytecode exclusive end, I think it should be if it's greater than or equal to that, then bytecode of offset plus 1 is equal to target minus bytecode deleted count. Okay, so it's just going to back it up. Else, if the target, so in this case, that means it's less than the bytecode. If it's greater than or equal to bytecode, where does it start? Oh, start. Then that means target was jumping to an opcode that is now deleted. And what do we need to say? Offset plus 1 is equal to bytecode start. Why? Because if we were jumping into the middle of something and whatever was after it, so we deleted a bunch of stuff and we now have moved this up, we want it to point to wherever that was. Yeah. And what if it was less than that? We don't do anything. For this loop, however, order. Okay. So this is the first thing. Or that's number 3, right? So we've got number 1, number 2, number 3, and number 4. Oops. Got it on the wrong window, but that's okay. Shouldn't you integer t be an unsigned? Did I make a mistake somewhere? Or am I just misremembering? Where would that be? Oops. I think that's been a problem now for a while. Somebody's probably seen that. Why didn't anybody tell me? Because nobody's watching the videos yet. See if everything still compiles now. I was afraid of that. So let's fix that. Edit. Source. Computed expression. Library math. 41. Oh, 27. And now the dump bytecode. Okay. Dump bytecode 128. Sorry, this is just fixing a lot of stuff that should have been fixed a long time ago. $575. What am I missing? So I don't get what the problem is here. So the first time it's telling me 310.83, which is where I am. Narrowing conversion of args0 from int to uint32. So if I make it a uint, then tells me an error in the exact same location of unsigned int to integer. Is it this? Okay. Now we're finally back to doing some stuff. 92, else if. Optimize, which means I'm probably forgetting something. Say like that. Hey, we passed our test. And that's after deleting something. Whereas before, We weren't. So let's check our jumps. So we deleted after 20. So if we had a jump, did we have any jumps before then? We had a jump to 49. 26 jumped to 49. And now 24 is jumping to 47. Okay. And are there any other jumps? No. All right, so it seems like we are done. What I'm going to do is take off the training wheels of our tests and let it run all the tests. There. Our make file at the bottom. Run it again. Oh, and we're done. 19 milliseconds. Well, that might be all the printing that we did. Let's do something else. Alright, so for all of these, this is one that did not get rewritten. No rewriting, no rewriting. And basically no rewriting for any of these. There was one that got rewritten right here. It went from 60 down to 58. Oh boy. 61 down to 59. A lot of these may only have one. There. Only print it out if there's a difference. How about that? That reduced a lot. So 60 down to 58. 59 down from 61. 54 down from 56. 54 down from 56. 70 down from 72. Oh! I did a short circuit, right? I'd forgotten about that. So 58 down from 60, okay. 59 down from 61. 54 down from 56. 54 down from 56. 70 down from 72. 45 down from 49, so that had more. 27 down from 29. 24 down from 26. 27 down from 29. 24 down from 26. 52 down from 56, so that had we lost a couple there. That's a good thing, right? 43 down from 45. 52 down from 56, so lost several there. 43 down from 45, and so on and so forth. Okay, and then if we go down to the bottom, were we still passing? Yes, we're still passing. So we had multiple things deleted, and I am leaving in this commented out code. Normally that's bad form, but it's because we're going to be coming back to it. All right, it did add some time. You would say, Corey, our optimizations added time. Yes and no. I mean, it did add time, but, and maybe we remove this in the end. The goal is more for optimizing on programs that will run repeatedly over time. So the amortized cost, can we say it that way, is better in the long run. So, okay, having said that, I think we're at a good stopping place, and we're, oh my goodness, almost at 3 hours. So let's see what all of our differences are. Now we know we've got the problem in the unsigned versus signed, so let's do that commit first. And on the right hand side, make clean and just make a clean test. Okay. Git diff. Okay, so our change in macros. Okay. There was something at the end there that should not be there. Okay, go back to our git diff. In the dump bytecode, we had a change. Yeah, let's add the dump bytecode. Dump bytecode, because I was a integer versus uinteger. Here's one in program-execute. Execute and look for that word optimize, because there is there. There was some white space. Oh, in our test file, and that didn't get rid of the white space. Why didn't it? let's redo that test then. It's always why I check my diffs. Yeah. Optimize the in program.cpp. .cpp line 159. Well, 2 down from that, but yeah, the white code difference is gone. And okay, now we're showing only 7 milliseconds. That's nicer. And we're doing a lot more processing, so okay, I can deal with it. So git commit fix problem where u integer t was not unsigned but should have been. Optimize git commit -am. Removing unnecessary value? Excuse me. Removing unnecessary CE creation. Also add bytecode deletion helper function. All right. We are clean. We are going to make docs-pdf, so update our documentation. Sorry, it's a long video. I know it is. Right at 3 hours. Oh, a lot of stuff changed. Episode, who knows what episode we're on? I don't know. 84. Excuse me. Episode 84. Get everything pushed. All right. So we've pushed that episode, and now usually we end up with counting our lines of code, and we're at 11,400 lines of code, 3,700 lines of comment. Some of those we know are some code that it's just there commented out because we know that we're going to use it in the next episode. But what we're going to be doing is looking at include Tang. Now, so what we've got is a push followed by a pop. That's the one that we just did, 19 and 20. We can now look through these and do number 1 and 2. So we did number 3. We can also add optimizations for 1 and 2. So, yeah, that's what we're going to do. And with that being said, we have come to a good stopping place. So thank you for joining me. And I know sometimes it gets a little long, but that's how programming is at times. It's just you write and write and write and write and write until you're done. So thank you again. Have a great day. Bye.